Good day, our beloved students. Today we will be demonstrating on the topic entitled Trigonometry, a super hexagon at its best. Before we proceed, let's define the super hexagon. A super hexagon is a one-of-a-kind shape that helps students visually retain all trigonometric identities and functions.
First and foremost, we must be able to properly label and create our super hexagon. We must join the opposing vertices of this hexagon to form three diagonals. We place the number 1 in the hexagon's middle. A single super hexagon can provide a number of formulas. In order to know the formula, we present the 6 function names of each vertex. Each of the vertices is given a distinctive label. We start at the hexagon's middle left side vertex and work our way down to the bottom left side vertex.
To begin identifying each vertex, we simply need to remember one formula. Tangent is equal to sine over cosine. Beginning with the central vertex on the left side, we write tangent, sine, and cosine clockwise. The next step is to write cotangent, which is the inverse function of tangent. All that is left are cosecant and secant. If we draw a vertical line across the hexagon center, 3 vertices on the left and right sides will be revealed, allowing us to determine where to place the following functions. To remember what is written in the vertex, we only need to remember that all of the functions on the right side begin with the letter C. This means that after writing cosecant, we write secant.
Moving on, now that we know how to properly label our super hexagon, we'll learn about the fundamental trigonometric identities. For the time being, we'll simply look at one fundamental identity, the reciprocal identities that can be obtained from the super hexagon. The reciprocal identities have 6 different formulations.
So how are we going to remember these 6 different formulations of the reciprocal identities using the super hexagon?
Now focus on the functions of diagonally opposite vertices: sine and cosec, cos and sec, cot and tan. They are reciprocals of each other. Look at this arrow for instance. This arrow tells us that sine theta equals 1 over cosec theta. If we change the position of the arrow, this arrow tells us that cosec theta equals 1 over sec theta. If the arrow is drawn like this, we can say that cot theta equals 1 over tan theta. If we rotate the arrow 180 degrees, we get tan theta equals 1 over cot theta. If we change the position of the arrow like this, we get sec theta equals 1 over cos theta. And lastly, if the arrow is drawn like this, we get cosecant theta equals 1 over sine theta. So remember, functions at diagonally opposite vertices are reciprocals of each other.
And that concludes today's explanation of the super hexagon and showcasing one fundamental identity in trigonometry through a mathematical manipulative.
Thank you for taking your time and listening to our discussion. We'll see you next time.